Hello, friends. Welcome to P.Bright Academy. In today's session, we'll be discussing methods of synthesis of two anti-malarial drugs. One is chloroquine, and second one is pamaquine. So this will be the last session of anti-malarial drugs of medicinal chemistry 3. So we'll go to the topic. So we have already seen the classification of anti-malarial drugs, and here you can see that there is star mark for two drugs. One it is coming in 4-aminoquinoline and the other is coming under 8-aminoquinoline, right? So under 4-aminoquinoline, you have to learn the synthesis of chloroquine, and under 8-aminoquinoline, we have to learn the synthesis for pamaquine. So we'll see first the synthesis of chloroquine. We have already seen the structure of chloroquine, and we'll see how it is synthesized. Okay, so this is synthesized from 4,7-dichloroquinoline. So we know the quinoline structure. So this is quinoline structure, and if we start numbering, it will start from the nitrogen atom to go like this, and this is fifth position, 6 and 7, 8. So in fourth position and in seventh position, you'll be able to see that there is a presence of chlorine, right? So this is 4,7-dichloroquinoline, and here we will use another reagent, which is diethyl amino 4-amino pentane. So this is diethyl aminos. That ethyl is present here. So this is CH3CH2. This is C2H5, which is nothing other than the ethyl group. So you have two ethyl group present here. It is attached to the nitrogen atom, and then we have the pentane. So if you count, you will able to see that there is 5 carbon group attached. So this is a pentane, and in fourth position you will see the amino function group. So this is 1 diethyl amino 4 pentane. So this is a type of condensation reaction. So what happens in a condensation reaction? We know that from each molecule something is going to contribute, right? From dichloroquinoline, the fourth position chlorine is going to combine with the hydrogen atom from the amino group of diethyl amino 4 aminopentane. Here, this chlorine, and from here one hydrogen will combine, and this will lead to the elimination of a molecule of HCl, correct? So one molecule of HCl is getting eliminated, and along with that there is a formation of new bond between this carbon atom as well as the 4 carbon atom. So there will be a bond formation, and this will lead to the formation of quinoline. So you'll be able to see that there is a bond formation between sorry, not the carb, yeah, between the carbon atom, between the nitrogen atom and the carbon atom. So this carbon atom and the nitrogen atom, right? The bond will be formed between the carbon and the nitrogen atom. So that you will see here, there is a bond formation between the nitrogen and the carbon atom, correct? So where is this methyl group present? That you'll be able to see here. So this is a methyl group, same methyl group, okay? And rest everything is the same. Rest everything you'll be able to see here, right? Rest everything you'll be able to see here. So this is the method of preparation of chloroquine. Okay, so methods of preparation are important, and they'll be asking for 2 mark or 5 mark questions. Now next is 8-aminoquinoline. Under this you have to learn the synthesis of pamaquine. So we have already seen the structure of pamaquine, right? We have the dialkyl amino alkyl substitution here, right? Dialkyl amino alkyl substitution here, and for the synthesis of pamaquine, we're going to start with this compound. It's 4-methoxy 2-nitrobenzamine. So we start numbering from here, amino position. Fourth position will have the methoxy, and second position will have the nitro group. So this is 4-methoxy 2-nitrobenzamine. All right, and here first we will make it to undergo Scropp's reaction. So Scropp's reaction requires three reagents. One is nitrobenzene, second is glycerol, and third is sulfuric acid. So what happens is that it will lead to a formation of a cyclic ring. So this here, it will form into a cyclic ring structure, correct? And you will be able to see that in this structure. Okay, so this is going to get converted to a cyclic ring structure. So this is new. This has happened after this crop synthesis, and the three reagents is important to remember. One is nitrobenzene, second is glycerol, and third is sulfuric acid. So this is a type of cyclization reaction. So you are able to see that here it, and then after crop synthesis it formed into a cyclate ring, right? So this is the reason why it's called as a cyclization reaction. Now what is this compound? We'll just try to see the basic ring. So from the basic ring you are able to understand that this is a quinoline nucleus. So on the sixth position, so quinoline nucleus, from where we should start the numbering, it should be from nitrogen, and then it goes like this, right? So if you see, if you will be able to see that in sixth position there is a methoxy, it's same. So previously what was it? It's same, but the number has changed. Now it is sixth position, right? And similarly, previously it was in second position, now it is in eighth position. That is, the nitro group is in eighth position, and this is called as 6 methoxy 8 nitro quinoline. Now in next step we are going to undergo a reduction reaction. So what happens, you are using a tin and HCl, which means it's a reducing agent, and here this nitro group will be reduced to amino function group. So NO2 will get reduced to amino function group, this position, and it will get converted to 8 amino 6 methoxyquinoline. So previously it was nitro group, now it is converted to the amino function group, and this is 8 amino 6 methoxyquinoline. So there is one more last step, which is a condensation reaction, and for condensation reaction we have to add diethyl amino 4 bromopentane. So that's the same structure we have seen, right? There is ethyl group present, which is attached to the nitrogen. Then we'll have the 5 carbon, correct? And in fourth position, you'll be able to see a bromine group present. So during condensation reaction, what happens is that a hydrogen from this position and the bromine, it combines together. So this two will combine together, and it will lead to the releasing of HBr. So hydrogen bromide will be released from this position, and it will lead to a formation of a bond between this carbon atom and the nitrogen atom. So a bond will be formed between the nitrogen atom and the carbon atom. So that you'll be able to see the nitrogen and the carbon, it has formed a bond here, correct? This results in the formation of a new bond. So everything else will be remaining. So this CH3, fifth CH3 group you'll be able to see here, and there is a carbon atom and it goes, right? So everything else remains the same. So during condensation reaction there is a removal of HBr, and that is how you are getting permaquine. So these are the two important methods of synthesis for the preparation of permaquine and chloroquine. So that it might come under 2 mark or a 5 mark category question. So it's important to learn the synthesis of important drugs, which as per the syllabus. So thank you for watching P.Bright Academy. Have a good day. Bye.